Hey, welcome. Have you ever stopped to think about how we measure something we can't even see but can definitely feel? Well, today we're diving into the wind and the really brilliant tool that lets us clock its speed.
Just think about it for a sec. Wherever you are, how fast is the wind blowing? Is it a light breeze? A strong gust? Without a tool, it's just a guess, right? It's just a feeling. But with the right gadget, we can turn that feeling into cold, hard data. So here's what we've got on tap. We're going to start with the absolute basics. What even is an anemometer? Then, and this is the fun part, we'll see how you can actually build one yourself. From there, we'll jump into the really high-tech stuff, check out how they're used in the real world, and find out they do way more than just measure speed. Okay, let's dive right in. First things first, what are we actually talking about here? What is an anemometer? Simply put, it's a device made to measure the speed of wind, or really any moving gas. And here's a little bit of trivia for you. The name itself comes from the Greek word anemos, which means wind. So it's literally a wind measurer. Kind of cool, right? And you might think this is some modern invention, but no way. The basic idea goes all the way back to 1450. It was first dreamed up by an Italian architect, Leon Battista Alberti. And his design was just beautifully simple. It was a disc that would tilt in the wind. The stronger the wind blew, the more it tilted. Simple, elegant, and it actually worked. All right, theory is one thing, but to really get how this works, there's nothing better than actually building one. So let's make this whole idea a lot more real. And don't worry, you don't need a fancy workshop for this. This is basically a classic 5th grade science project. You probably have most of the stuff, paper cups, a plastic bottle, some tape, just lying around your house right now. Putting it together is pretty straightforward, as you can see. The trick, the real key to the whole thing, is making sure all the cups are facing the same direction. That way, the wind is always pushing one cup while hitting the back of the opposite one. And that's what creates that nice, steady spin. So, how does this little paper contraption actually measure anything? Well, you just count. Seriously. Use a stopwatch, see how many times it spins in 1 minute. That's your revolutions per minute, or RPM. More spins means faster wind. It's that basic. And believe it or not, this simple idea is the foundation for a lot of professional grade models. Okay, so keep that spinning paper cup model in your head. Now, let's see how that basic concept gets a major upgrade as we jump from simple mechanics to some seriously high-tech sensors. So the two most common mechanical types are basically direct descendants of our little DIY project. You've got the cup anemometer, which is exactly what we just built, just, more durable. It's great for measuring speed. Then you've got the windmill anemometer. It adds a tail, called an aero vane, that keeps the propeller pointed right into the wind. So with that one, you get both speed and direction. Okay, but this is where things get really wild, because we're moving past anything that physically spins. A hot wire anemometer, it has a tiny heated wire, and it just measures how fast the wind cools it down. Then there's the laser Doppler, which literally shoots a laser and measures the light bouncing off dust particles in the air to see how fast they're moving. And the sonic anemometer sends sound waves between sensors to measure tiny shifts in their speed. I mean, think about that. There are no moving parts that can freeze up or break. We are literally measuring the invisible with the invisible. This tech is just incredible. But it's not just a cool science experiment. Why does any of this actually matter in the real world? Well, the list of people who rely on this is huge and really diverse. You've got meteorologists trying to forecast the weather, drone pilots trying to keep their shots stable, pilots, skydivers, even long-range shooters. For all these people, knowing the exact wind speed isn't just a fun fact, it's absolutely critical. Yeah, let's make this real. Imagine you're a skydiver. That wind reading isn't just data, it's a vital safety check. Knowing that velocity before you jump out of a plane, well, that's the difference between an amazing experience and a really bad day. And for a pilot, the stakes are just as high. Anemometers are a key part of what they call the pitot-static system, and it's constantly measuring airspeed. That one number is crucial for everything from takeoff to navigation to landing. It is one of the most important instruments in the entire cockpit. And let's bring it full circle, back to that crazy advanced tech. Remember that laser Doppler anemometer? Well, aerodynamic engineers use it to see the super complex, super fast airflow happening inside a jet engine. That's how they design engines that are more powerful and more efficient. So we've gone from counting the spins on paper cups to bouncing lasers off dust particles, all to measure wind speed. But it turns out that's not the only thing these amazing instruments can tell us. Yeah, it's really important to get that this isn't a one-trick pony. Beyond just telling you how fast the wind is moving, it can also measure wind pressure, like the actual force the wind is pushing with, as well as its overall flow and, of course, its exact direction. Think about that journey for a second. We went from a simple tilting disc back in the 1400s to using sound waves and lasers to get these incredibly precise readings of the air all around us. It's just an amazing story of innovation, all to understand an invisible force that literally shapes our world. Which kind of makes you wonder, doesn't it? What invisible force will we figure out how to measure next?